Okay, yes. Okay, good afternoon all. Yes, good afternoon. Last day I just starting symmetric and asymmetric encryption. Okay, we will do theory today also because we have to do a lot of theory parts. Later on we will discuss about practical. Okay, don't worry about that one. Sorry for that one. I have to continue theory because they are having to discuss a lot of theories there. Okay, that's why. We will discuss practically further on. Okay, don't worry. Okay, last day we are just starting symmetric and asymmetric encryption, as I remember. Yes, I just said what is the encryption. There should be have encryption when we are sharing messages with each other. Otherwise, it is actually for security purpose. When we are sharing messages from one person to other person, that message can be encrypted. Okay, for what minimize the risk. The message can be encrypted for minimizing risk. So such that they are having encryption. So encryption, it's altered data into form that unreadable by anyone whom to the data is not intended. Okay, so it cannot prevent a data being intercepted, but it is stopped from making any sense for everyone. Okay, we discussed that thing on the last day. So today it's very important. Actually, encrypted, how to work encrypted, and what is the plain text and what is cybertext. Okay, so this is very important. We will discuss today. Okay, write down plain text and cybertext. Important topic. Write out there plain text and cybertext. Okay, actually, what is the plain text? Plain text is actual message. Okay, plain text is known as the original data, original message. We have to convert that one using a ciphertext. What happened? Here the sender. Sender sending the plain text, normal message. They are having something like encryption algorithm. Okay, they are having something encryption algorithm. I just said something. Using that encryption algorithm, the plain text is converted for the ciphertext. What happened? Using that encryption algorithm, you can convert a plain text into the ciphertext. Okay, here it's converted plain text into the ciphertext using encryption algorithm. Okay, now the ciphertext going through the internet, and again it decrypt using the algorithm. Okay, here plain text using an encryption key, it is converted for the ciphertext. Okay. Okay, ciphertext again using the decryption key. Decryption. Here encryption. Here have the encryption scenario. Here they are having decryption. Decryption means now they are having ciphertext. Ciphertext again. What? Converted for the plain text. That's calling what? Decrypt. And here receiver can be what? Read the message. So anyone in the internet try to take a cyber attack. There can be have what? Hackers. In between hackers can't read this message because the third party hackers can't read this message because already it is encryption. After going through the internet, it decrypted and it can be read by the receiver. That's the scenario. Okay. That's the scenario. There should be have two keys. That what? Encryption key and the decryption key. It should be have for two members, that receiver and the what? Sender. Sender and receiver has two keys. How? It's like a box. Okay. First of all, in the box, using encryption key. Use this encryption key. The box is locked by sender and box is going for the receiver. After that one, it is unlocked. Unlocked by the decryption key and it can be read like that. they are having two keys with the two members, sender and receiver, can be locked and unlocked by them. Okay, like that scenario they are having. So plain text and ciphertext. When we discuss about that one, it's really important. What is the difference? The original data being sent known as a plain text. Yes, the original data being sent and known as plain text. One it gone through an encryption algorithm, it produced for the ciphertext. What happened? Once it has gone through an encryption algorithm, it produces for the ciphertext. It's production for the ciphertext that calling as what? Decryption algorithm. Here the scenario. Okay. This should be the scenario within that one. Okay, shall you write down this? First of all, write down and also draw this figure. It's mentioned plain text converter for the encryption key using encryption algorithm with converter for the ciphertext, and ciphertext again decrypt and can be read by the receiver. Okay. Okay, and write draw this figure also. Take time. Okay, I think you got it. The original data being sent known as a plain text. Once it's going through the encryption algorithm, it produces for the ciphertext. Okay. Okay, write it down. Yes, write down. Okay, write it down. Draw the figure. Write it down and draw the figure. Yes. You can write and draw the figure. Okay, write it down. Here the scenario. Yes. Okay. I think yes. Okay. Okay. Yes. Okay. That's the plain text and the ciphertext difference. So there I have it with this what plain text. Here in this scenario, there should be have what a proper encryption method. That algorithm maybe have symmetric and asymmetric. What is that? Okay, we will discuss. Okay, it's important. Okay, write down the symmetric and asymmetric encryption. Symmetric, like equal both side. If they are having symmetric axis, it is equal for both side. That's calling symmetric. Asymmetric means it is not equal for both side. Okay, write down symmetric and asymmetric encryption. Symmetric and asymmetric encryption. So, in symmetric encryption, uses an encryption key. Okay, a symmetric encryption uses an encryption key. The same key is used for the encrypt and the decrypted encoded message. For send message, and it is encrypt using a key. Here the internet is go and decrypt that same key and receive it. These two, encryption and decryption, both key are same in the symmetric encryption. Is that clear? In the symmetric encryption, the encrypted and the decrypted, both key are same. Okay, so write down that one. First of all, write it. The encryption and decrypted, both key are same in the symmetric encryption. Okay, right there. Symmetric encryption uses an encryption key, the same key used for the encryption and the decryption encode message. Put that strict bracket right. Symmetric encryption uses an encryption key. The same key is used for the encryption and the decryption encode message. So first of all, consider a simple system that uses 10-digit binary encryption key. It's give 1 into 10 possible codes. And a decryption key, suppose all the encryption key is. Okay. So here a encryption key. Here it is a encryption key. Here, which means every letter in a word shifted across the alphabet plus 4 plus 2 plus 9, all of the plus 1 and so on. Please. For example, here the message, computer science, look at it, exciting, plain text. Okay, computer science is exciting. Here the message I wanted to send. Before after applying this encryption key, formatting the ciphertext shown as the below line. Okay, what happened? Okay, here computer science is encryption. Okay, now they are having key like this. What is 4291362856? Again, 4291 like that. Three same key again. So here the algorithm do like this. Here add in 4 C D E F G. Add in 2 O P Q. Add in 9 M N O like that one. 9 letters go forward. 1 letter P Q. 3 letters U V W X. Such that there are generate another message according to that one. Here computer science is exciting. Here the generate key and it's going like this. After that one, when it is decrypted, it is minus. Here +4, +2, +9, +1 subject. When you are decrypted that one, it is again minus. What is there? -4 for G, -2 for Q, -9 for V, -1 for Q, such that they are working. Is that clear? It's working like encryption and decrypted like that. Okay, it encrypted and decrypted like net. Okay, that is the possible way it's running on. Okay, that's the possible way that it is running on as an encryption and the decryption. Clear? That's the way you should be following up. Okay, so can you write down this thing? So, like here, write as an example. Write as an example. Suppose our encryption key is this one. So, here is the message. Computer science is exciting. Okay. Before and after applying the encryption key, it's look like here. And you can draw these figures. Okay, can you write down? I think you got the point. Okay, according to this one, it's adding 4 times per postulate, adding +4, adding +2, adding +9, +1, +3, +6, such that. It's working such that. Okay, first of all, write down it. Write all the thing here. Here mention in encryption and decryption method. Okay, write it down. Right. Yes, write it down. Okay, write down these things. Box and under. Okay, write it down. Yes. Here the symmetric encryption, and here the way you have to follow it on. Here the way you have to follow it on. Yes. Write it down. Yes. Okay, write it down. Yes. Write it. I think you can get the idea. I think you already get the idea how this one change. Here plus 4, here plus 2, here plus 9, such that. Yes. Maybe change like that. Okay, do it. Yes, I think you wrote that down, no? Yes. Okay, like that one, it can be encrypted. When you decrypt it on, it's go for the reverse versa. Here G go for the -4, it becomes C. Here O go to the -2, it become Q goes to -2, it become O. Such that it can be go for the reverse versa also. Okay. When it is decrypt, it become for the reverse. Okay, like that one it can be happen. Okay. Encrypted and decrypted. Both should be there. But both using the same key, but it's go for the reverse. Clear? Here, for example, I give in. Okay. So they are using both key. So, however, modern computers could crack this encryption key in a matter of seconds. Okay. In modern computer, it can be crack this encrypted key within few seconds. Today, yes. So we now use 256-bit, 256-bit binary encryption keys that give 2 to the power 256, approximately something very big value. There can be changed 2 to the power 256 times. It can be changed. Can be changed. How many times you can analyze it? Okay, possible combination. So enough. We head toward quantum computers. In modern in the quantum computers, they are having encryption key with the 256 2 to the power 256 of a compute. Okay, that's calling with the quantum computation. No need to write that one. The real difficulty key is keeping the encryption key secret. But for example, it needed to send email or text message with the intercept. So the real difficulty is keeping the encrypted key as a secret because we have to send that one. When someone try to catch that encryption key and try to decrypt the message. So therefore, the issue is security always main drawback of the symmetric encryption. So always, if they are a third party, that cyber attacker, the hacker can be get that encrypted key while you are sending this one. The It can be easily decrypted because decrypted using the same key. Clear? That the drawback of this one. Okay, so write down that one. The real difficulty is keeping encryption key is secret. What is there? The real difficulty is keeping encrypted key secret because you have to send it by email or something. Sorry. Right there. The real difficulty is keeping encrypted key secret because you have to send it. So therefore, the issue is security. The issue is security is always main drawback of the symmetric encryption. The issue of security is always the main drawback of symmetrical encryption since the single encryption key is required both send and reception. Since a single encryption key is required both send and the reception. That's the issue. So the real difficulty is keeping encryption key a secret. So therefore, the issue of the security is always the main drawback of symmetrical encryption. So therefore, the issue of the security is always the main drawback of symmetrical encryption. Since a single encryption key is required for both send and the reception. Since a single encryption key is required both send and the reception. That's about that. Yes, write out that. Write out. Okay, write it down. Okay, yes. So next thing is asymmetric encryption. In the asymmetric encryption, they are not using same key or the what encrypt and decrypt. They are using different key. So it having more security rather than symmetric. Okay, so in the asymmetric encryption was developed by overcome the security problems. So they are having a lot of security problems with what? Symmetric encryption. So because of that one, they are using asymmetric encryption. Because of why? Asymmetric encryption was developed to overcome the security problems associated with the symmetric encryption. So it makes use of two keys called public key and the private key. So they are using two keys. Okay, there can be used two keys that call public key and the private key. So public key and private key, there are two keys. Okay, we will discuss about that one. Okay, so both types of key needed to encrypt and decrypt message. The public key and the private key, both type of keys should be needed for encrypted and decrypted message. Okay, write down this one. So asymmetric encryption. Asymmetric encryption was developed by overcome the security problems. To overcome the security problems, we have created asymmetric encryption that associates with the symmetric encryption. So it make use of two keys called public key and the private key. Let's make use of two keys called public key and the private key. So public key made available to everybody. Private key only known the computer user. Private key is only known the computer user. But public key made available to everybody. So both key needed to encrypt it and decrypt the message. Okay, write down that. Yes. More needed encrypted and decrypted message. Not only public key, not only private key, both should be needed. So asymmetric encryption was developed to overcome the security problems. It associated with the symmetric encryption. So it make us use of the two keys called public key and the private key. Actually, public key made availability for everybody. Private key only known for the computer use. So both type of key are needed to encrypt and decrypt the messages. Yes. So they are having an example for you. Look at it, they are having two keys. Okay, here we will use an example to explain how this works. Okay, we'll see. Suppose Tom and Jane work for the same company and Tom wishes to send some confidential document for Jane. What happened? There are two members, Tom and Jane. So Tom tried to send some confidential, something like account details, okay, sensitive details for with confidential company details for Jane. Okay, so Jane uses algorithm for generate matching pair of keys. Okay, Jane use algorithm. Okay, Jane uses an algorithm to generate matching pair of keys. It's private and public, so that they must keep stored on their computers. So matching pairs of keys are mathematically linked but can't be derived for each other. So Jane now send public key for the Tom. Okay. Jane only send the public key for the Tom. They are having two keys with Jane, public key and private key. But Jane only send the public key for the Tom. Okay, now Jane send his public key for the Tom. Okay, Tom, they are having a public key. Now, Tom used that public key to encrypt the document which is to the sender. And he sent to encrypt document back to the Jane. Using the public key, Jane sent back to the what? Sorry, Tom Jane sent back to the Jane. Jane used a matching private key. After that one, after taking that message, Jane uses a matching private key to unlock Tom's document and decrypt it. Okay, this works because key uses encrypted document and private key uses for the decryptor. So it is a matching pair generated Jane computer. Okay, so there are intermediate people can't take what's the actual process. Okay, so like that one, they are having encrypt and decrypt it. Shall we write down this procedure? It may be a little long, but it's very important. Write only underline part like this. Tom wishes to send the confidential document for Jane. Okay, now Tom wanted to send a confidential document. Jane have two key, public key and private key. Tom had public key after sending by Jane. Okay, first step, Jane uses an algorithm to generate matching pair of key. Okay, Jane uses an algorithm and generate matching pair of key that they must keep stored their computers. Okay, the matching pairs of key are mathematically linked but can't be derived from each other. Okay, J now send the public key for the term. Okay, write down this, draw this figure roughly. Okay. Okay, write all the part 1, 2, 3, 4. Give times and draw the figures as well. Okay. Take time, okay? Write that. It's very important. Okay, write it down. Yes. Yes. Write down them. Write down quickly. Write it. So Jane now send the public key for the Tom. Okay, after now Tom already know use the now Tom can use the Jane public key to encrypt the document he wish to send her. Okay, what is that? Now Tom is using Jane what? Public key for the generate. Okay, he then sent his encrypted document back to the Jane. Now Tom send back to the Jane. Now Jane have private key. Okay, write it. Yes. Now use it. Now use Jane public key for the encrypted document. Now Tom use Jane public key for the encrypted document. Okay. So Tom use Jane public key for the encrypted document and wish to send that document for her. And he then send his encrypted document, the ciphertext back to the jail. Okay, he sent back to the jail. Finally, Jane uses a matching private key. Okay, finally Jane uses a matching private key to unlock some document and decrypt it. Okay, so now Jane can use her matching what private key for unlock Tom's document and decrypt it. This work because the public key use this works because the public key used for the encrypted the document and private key is used for the decrypted matching pair generated Jane computer. So both matching pair has a Jane computer, so Jane can be what decrypt that message. That's a final scenario. We write down now that the normal thing, normal scenario that should be following up using asymmetric key. When you're using asymmetric key, that the normal scenario should be following up. Okay. Write it down. Yes. Write down. Okay. So you can see they are having matching pair like that. Public key and the private key. They are having matching private key and the public key. such that they are matching pairs. Yes. Okay, write it down. Yes. Okay, write it down. Yes. These are the way you have to following up. Okay, the public key, use the public key, and after that one, generate for the private key, and finally matching private key for the unlock that. Okay, that's the way you have to following up. Okay. Yes. So here the activity for you. At this moment, Jane can only receive an encrypted document from Tom. Describe what would need happen to Jane to able send encrypted document back to Tom. Okay. Explain why this method is much more secure than symmetric. You can tell why this one more symmetric, what more accurate, more security rather than actually not accurate, security rather than private key. Okay, if I didn't write it quickly. Yes. Okay, write them down. Yes. Okay, I think you already finished these things. Okay, we will discuss further thing here. If you Jane can also exchange his public key with the any number of people working in the company, not only one person. He can exchange for the any number of key. So she will encrypted message. She is able to receive encrypted messages with have seen encrypted using the public key, and she can then decrypt the message using his private key. Like that one, not only one person, She can be shared for many persons. Okay. At home, write down this part. Okay. Also, so you can write down this part as a homework. Not only one person. Not only one person. She can share for the Jane can be also exchange the public key with any number of person working in the company. So it's able to receive encrypted message. Okay. And she can then decrypt the message using matching private key. Okay. You can write it down later on. Okay. So write down that. We will discuss other thing on next day. Okay. This is very important because this cybersecurity is very crucial document topic when you are working on the later on in the ICT. This one really important. That's why I said. Okay. Please follow with this one. We will discuss on the next day. Okay. So I think it's almost time up. We will discuss other thing on next day. So thank you very much. We will see on the next day. Okay, so good afternoon all. See you next day. Okay, good afternoon.